Hello everyone, welcome back to my YouTube channel. I remain your global math teacher. To my already subscribers, thank you so much. Thank you so much. And if you're new here, welcome to my YouTube channel, where we deal about everything that's to do with mathematics. So we started off from our last class um, on calculus, specifically differentiation, and we've done about three rules. Yeah, if I'm not mistaken, we've done power rule, we've done product rule, we've done quotient rule. Now we're looking at chain rule. Now, what is chain rule? Chain rule is a formula that is used, a formula in derivative that is used to calculate or get derivative of a composite function. That is a function that has another function in it. That's basically what we're talking about. So today I'm going to be running you through two different methods you can use in getting your derivative when you're using chain rule. The first one might be a little bit confusing, but I will run you through the second one before I go back to the first one, the first method. I wrote the first method here. I said I have if y is equal to f of g of x, then the derivative of y is simply derivative. I said if y is equal to f of g of x, then derivative of y is simply derivative of f, all in brackets g of x, then dot we have derivative of g with respect to x. That's the first method. But I'll run you through the second method so that me talking about the first method makes it much more easier for you to relate with. Now let's look at the second method. Second method is called outside inside method. It's one you kind of substitute. That is, you make something to be this, then you start using your substitution and stuff like that. Now we said dy dx is the same thing as well. Dy du times du dx. Literally, if you look at it, you will see that if I cancel out du here, du goes out here, I'll be left with dy dx. That's basically it. So let's look at an example here using the outside inside method first. Then we go back to using the first method to make it much more easier. The first method is the general method that's acceptable anyway. Second method is also accepted, but this is what you're going to get. The first method, anywhere you go to, everywhere you go to, that's what you're going to get. Now let's quickly look at this. Now we said if y is equal to 2x plus 1 all to the power of 3, what am I expected to do? I'm using the second method now. So the first thing I would love to do here is to let 2x plus 1 to be equal to u. After I do that, I'm bringing this now. I'm assuming myself. It's not like I was told. You can make it any letter you want. You can make yours PM, but just be very careful that when you're writing the formula, you are using what you use. You're not using something else. And also be careful not to use the variable you're given, x and y. You can't use it. You have to use something else other than x and y. So it's best to just stick with u and be good. Now, let 2x plus 1 be equal to u. Then if this is equal to u, I'll rewrite my y. My y becomes what? It becomes y, which is equal to u to the power of 3. Now remember that this formula says what? Dy dx is equal to what? Dy du times du dx. Now it tells us that I need what? Dy du. I also need what? Du dx. So I need to get the derivative. I need to get derivative of u with respect to x. I also need to get derivative of y with respect to u. Now let's do that now. So let's get this. Dy du is equal to what? Is equal to 3u, that's 3 minus 1. Then this becomes 3u to the power of 2. What about this? Du dx is equal to what? Simply just 2. That's all. So let's quickly slot that into this formula and see what we're gonna get. Dy du is what? Dy du is 3u to the power of 2, right? Times du dx. Du dx is what? Times 2. So this becomes what? 6u to the power of 2. But we need to recall. What is u? What do you say u is? Recall that u is equal to what? U is equal to 2x plus 1. Then now we substitute it back here. So this becomes what? 6 2x plus 1 to the power of what? 2. And I'm done differentiating this function with respect to x. So my dy dx is simply what? 6 2x plus 1 to the power of 2. That's basically it. Now, if I'm to use this first method, now what would I do? Now, this first method, I have that y is equal to 2x plus 1 all to the power of 3. And I'm asked to find the derivative of y. What do you do here? Very easy. Firstly, bring down your power. That is, make your power just as when we do power rule. Remember that what we used to do there. What we do in power rule, bring down your power, make sure it multiplies what you have here. So if I bring down my power, it becomes 3, right? Dot differentiate what you have inside here. If I differentiate what I have inside here, it becomes what? 2, isn't it? Then I rewrite the whole of this back. 2x plus 1. Then I subtract 1 from this and it becomes 3 minus 1. So I simply have what? 6, 2x plus 1, then 2. And that's it. It's shorter, right? Yes, it is. But in some other functions that it might be a little bit tedious. You might not know what to do. So I recommend the outside-inside method. That's very safe. Like, it's so safe. You are just playing safe. But if you know you could do the second method, that's fine. So make sure to like, comment, and subscribe. And see you in my next video. And whatever topic you want us to talk about, you can just drop it in the comment section. Bye.